In the previous video, I promised to teach you how to use right-angled triangles to solve geometry problems. But before we do that, let's find out why we need them at all. Firstly, it has certain properties that make geometry calculations easy. Not only that, we can apply these properties to all right-angled triangles in the GRE to simplify the calculations. How, you ask? Well, let's find out. First things first, I want to ask you, what happens when you cut a square diagonally? Will it cry, bleed and ask for mercy? Well, it may do all those things, but also give us two identical triangles. As you can see, we have a 90-degree angle, two 45-degree angles and two equal sides. This is nothing but an isosceles right triangle. Fun fact, the word isosceles was derived from isos and skelos in ancient Greek and it means equal legs. Also, the sides of the triangle are in the ratio of 1:1:√2. That's interesting. But how did we arrive at that ratio? Well, we simply applied the Pythagoras theorem. If we assume the two equal sides to be 1 unit each, then the hypotenuse is measured using the formula AB square is equal to AC squared plus BC squared. Therefore, AB is nothing but the square root of 2. That's how we arrive at the ratio 1:1:√2. Now that you know this ratio, you may simply substitute the known lengths to find the unknown length. Easy, right? Now the next rad is something I like to call the danger rad. Yes, I said danger right angle triangle. Why did I say that? Well, unlike the isosceles right triangle, this triangle sides ratio is a bit complicated. This triangle has all unequal sides with angles 30, 60 and 90. And the opposite side to these angles are in the ratio of 1:√3:2. See, it is not simple like the 1:1:√2 ratio, which is why I refer to it as a danger rad, because it's easy to make calculation mistakes. But we'll make it easier. Let's see how we arrive at this ratio. Consider this equilateral triangle. Now we know that an equilateral triangle has all equal sides and each angle is 60 degrees. Let's assume that all the three sides are A units in length. When we draw a perpendicular from A, it equally bisects BC. The length of AD becomes A by 2. Now consider triangle ABD, where angle ABD is 60 degrees and angle DAB is 30 degrees. Correct? On applying Pythagoras theorem, we get AB squared is equal to AD squared plus BD squared. Let's consider AD to be x. So A square is equal to x square plus A by 2 the whole square. And so on solving for x, we get x is equal to A by 2√3. Now the ratio becomes A by 2 is to A by 2√3 is to A. When we simplify this, we get 1:√3 is to 2. Again, now that you know this ratio, you may simply substitute the known lengths to find the unknown length. There you go. Now all you have to do is remember these two ratios and you can solve geometry questions in the GRE exam without learning trigonometry. You can thank me later. Until next time, keep practicing.